what if the solution to a massive industrial-scale problem wasn't a bigger factory or more heavy machinery, but the supercomputer that's probably sitting in your pocket right now? Well, that's exactly what we're going to break down today, how a regular smartphone is being used to completely reinvent waste management. You know, the stakes here could not be higher. This quote from the project's own documents just sets the scene perfectly. For industries that generate enormous amounts of waste, the old way of doing things, just trucking it all to a landfill, is over. The writing's on the wall. It's not a choice anymore. It's an inevitability. And this is the answer. What you're looking at here is the architecture for what's called the Digital Refinery. It's a new system from a company called 950 Wood. Think of it as a smart bridge, using technology to connect the messy, chaotic world of industrial waste with the super precise, high-value world of the bioeconomy. Okay, so let's really dig in here. To get why this is such a game changer, you first have to understand the sheer scale of the problem that it's designed to solve. Get this, every single year, just in the province of Ontario, industries create 4 million tons of what they call orphan waste. This is stuff that doesn't have a simple, clear home for recycling or disposal. It's just a massive logistical and environmental nightmare. And it's fast becoming a huge financial problem, too. There's a new regulatory penalty, the CIRCI levy, that's designed to force companies away from landfills. It's hitting them with a $60 fine for every single ton of waste they don't properly divert. You can imagine how quickly that adds up. So you might be thinking, why is this so hard? Can't you just sort it? Well, here's the kicker. It comes down to something the project calls the visual fallacy. And it means you just can't trust your eyes. To you or me, or even a normal camera, a piece of clean, usable pine can look exactly the same as an old piece of wood that's been treated with arsenic. One is a valuable resource, the other is literally hazardous waste. So how on earth do you solve a problem that you literally cannot see? Well, this is the turning point in the story, because the solution comes from a place that is completely unexpected. And this is the part that just blew my mind. The answer isn't some billion-dollar sorting facility with giant conveyor belts. Nope. It's a next-generation Google Pixel phone powered by their absolute latest AI chip. Now, this is all possible because of a core concept they call the tactile edge. The idea is actually pretty simple, but the implications are huge. You take all the brainpower of a massive data center, you pull it out of the cloud, and you put it directly into the device that's on the front lines. What that gets you is instant, smart decision-making, right there on the spot, even if you're in a concrete basement with zero cell signal. Okay, so how in the world can a phone do all this? This isn't just some fancy app. It is a deep, fundamental integration between custom-built hardware and incredibly optimized AI. Let's look under the hood. Right at the heart of it all is Google's Tensor G5 chip. What's so crucial here is that this thing is built for industrial work. That advanced 3-nanometer process means it has incredible thermal stability. It doesn't overheat. It doesn't slow down. It can maintain peak AI performance for a full 8-hour shift without even breaking a sweat. Now, the AI brain of the chip, the Tensor Processing Unit, uses a special design called a systolic array. Honestly, the best way to think of it is as an assembly line for math. Data just flows through this grid of processors, and each one does its little piece of the calculation and passes it on. This lets it perform a staggering 65,000 operations per clock cycle without the usual bottleneck of constantly having to go back and get data from memory. It's just insanely efficient. But look, brilliant hardware is only half the battle. To get that incredible speed, the AI model itself is optimized through a process called quantization. As this table shows, what they do is reduce the precision of the numbers the AI is working with, going from a complex 32-bit format all the way down to a simple 8-bit integer. Yeah, you lose a tiny bit of precision, but what you gain is a massive speedup, giving you maximum throughput right there on the device. And the software that acts as the master conductor for this whole orchestra is LiteRT. You might know it by its old name, TensorFlow Lite. This is the framework that deploys that super optimized model onto the chip, and it's what makes the whole system deliver that critical, clean, or treated verdict in less than 2 seconds, no matter where you are. So we've got the chip, we've got the AI model, we've got the software. Now let's see how it all comes together in a powerful, real-world workflow that people are using every day. This flowchart basically shows you how the AI thinks, and it's not just a simple visual check. After the AI analyzes the photo, it does a second, absolutely crucial step. It checks the wood's origin. If it came from a high-risk source, like a demolition site, the system automatically triggers a mandatory secondary inspection. It's been programmed with a precautionary principle, refusing to trust the visual data alone when the stakes are high. So here's the entire process, step by step. First, intake. The user snaps a photo, and the phone's local AI makes a call in under 2 seconds. Second, verification. Any high-risk source triggers a mandatory alert for more screening. Third, compliance. A secure, unchangeable certificate with a blockchain hash is created for the audit trail. And finally, my favorite part, the incentive. The user gets immediate visual feedback as the user interface shows that $60 ton levy dropping to zero. It's brilliant. And this whole system is designed to be legally bulletproof. When it rejects a load, it doesn't just say no. It actually cites the specific section of Ontario Regulation 347 that was violated. It automatically files the official hazardous waste paperwork and creates this perfect, unchangeable audit trail that can literally replay the entire decision-making process for government auditors, even years down the road. All of this technology is absolutely incredible. But for any business, it has to answer one key question. What does it mean for the bottom line? Let's connect the tech to the money. The financial impact is just massive. I mean, this simple chart says it all. For this one specific load, traditional landfill disposal would have cost $12,000. By using the digital refinery to properly divert the clean material, the cost plummets to just $4,000. That is an $8,000 savings on a single truckload. And for the clients generating the waste, this isn't some abstract number on an invoice they get weeks later. They get a live dashboard. They can see in real time exactly how much money they're saving by avoiding those penalties. And just as importantly, they can see their positive environmental impact, tracking the tons of CO2 they've helped sequester. What this really represents is a fundamental shift in thinking. The old model turned your waste into a disposal receipt and a regulatory penalty. It was a liability. This new model transforms that exact same material into a revenue-generating asset that can even pay you a carbon dividend. It completely rewrites the economics of waste. Okay, let's just pull back for a second and look at the big picture. What are the broader implications of this incredible fusion of technology and heavy industry? This final quote from the developers really captures the vision perfectly. This project isn't just about sorting trash better. It's about creating a sentient bridge, an intelligent, responsive connection between the messy, chaotic reality of industry today and the clean, precise, and profitable circular bioeconomy of tomorrow. And this leaves us with one last, really provocative question to think about. We've just walked through how a smartphone is reinventing a foundational industry like waste management. So it makes you wonder, what's next? What other trillion-dollar industries are just waiting to be completely transformed by the AI supercomputer that pretty much all of us carry around every single day?